Hello, math magicians. Today we're going to be looking at a concept called Slope-Intercept Form. Our goal is to write and graph linear equations using this crazy and brand new idea, Slope-Intercept Form. Alani wants to buy a $360 bicycle. She is considering two payment options. The image shows option A right here. Full price is there, which consists of making a down payment and then smaller, equal-sized weekly payments. Option B consists of making 6 equal payments over 6 weeks. Now, your job is not to find out how much she has to pay. That's not our job. We're not solving anything. All you're going to consider right now is what factors should Alani take into consideration before she decides which of the two options to choose. Next, suppose Alani could modify A, option A, and still pay off the bike in 5 weeks. Describe the relationship between the down payment, this column, and the weekly payments there. So take some time to consider that. All right, now that you've done that, we're going to look at this idea of slope-intercept form. And slope-intercept form is always for linear equations, and there are just 4 letters. Tell me y equals mx plus b, or something like that. So, first off, x. X is called the independent variable. Independent variable. And usually we think of x as the input, the stuff that goes into a function. All right, next up, we have our y. Our y is dependent variable, and we consider that to be our output. Now, we're not saying that that y always is dependent on x. What we're just saying is that when they're in this order, then this is called the dependent and this is called the independent. Okay, next, m. M, we already know what M stands for, and it stands for slope, derived from like mountain slope. And this specifically helps us out. Later we're going to see it's going to help us how to move our line around. And lastly is B. B stands for Y-intercept. And B is important because it tells us where to begin on the y-axis. B for begin, M for move. So that brings us right here to graphing and using slope-intercept form. So we're going to graph this y equals positive 3/5 x plus 2. Our first thing to identify is where to begin. What is our beginning point? Well, we recognize that B, our y-intercept, is equal to 2. So we know that on the graph, which we haven't done yet here, so if I were to take a moment to make crosshairs, so here's my y-axis and here's my x-axis. I'm going to throw a few numbers down just for scale. All right, we do know we begin at positive 2, so I place a point right there. Next up, it says, how do I move? What is my m? Well, remember, that's what this is right here, m. And that can be interpreted in 2 ways, and both of these are equally valid. So my m is 3/5, but remember, this means my rise over my run. So what does that mean? Well, it means I can go up 3 and then right 5, but alternatively, I can go down 3 and left 5. Why is that the case? Well, because remember that negative 3 divided by negative 5, the double negative right here, becomes positive. So we can interpret both of them being negative or both of them being positive. So let's now do 3/5 over here. Now I'm going to start counting. I go up 1, 2, 3, and then right 1, 2, 3, 4, 5. So again, that goes up 1, 2, 3, so up 3, and right 1, 2, 3, 4, 5, which places it my second point right here. Now, had we done negative, it would have looked like this, negative 1, 2, and 3. So negative 3 takes me to that position, and negative 5, it's going to take me off grid here, but it should be okay. Negative 1, 2, 3, 4, and places it to be right here because that's left. Now, notice what's true about all these points? These points are collinear. So as I draw my line, they're going to go through all the points right there. And so here's a graph of this equation. Your job here is to go ahead and describe and sketch the graph of this function. You can pause here and check your answer in just a moment. So here are the answers, and let's check this one. This one begins at positive 3 on the y-axis, and then the slope here is sort of hidden. It's a 1, which means go up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1. Over here, we begin at negative 5, which is located there, and either we can interpret this as negative 2 over positive 3, or 2 over negative 3, which means I can now interpret this as down 2, right 3, which is what this one gives me, or up to left 3, which gives me that. Again, they're equivalent, and it doesn't actually matter which one you choose. But you can't, we shouldn't put negatives on both of them, because then that brings us to a positive. Now we're going to write the equation of the line from a graph using slope-intercept form. So what's the equation of the line in slope-intercept form? So two things we need, of course, is the m and the b. So the m, as we know, is going to be a counting situation, and the b is just something we can point out. Where do I begin? Well, remember that this is my y-axis, so I'm just trying to see where my line crosses that y-axis. So that brings me to right here. So this is a number I can just point to. Here's 0, so that's a 1. And that's a 2, that's a 3, so this has to be 1. So there's my b, excuse me. Now, how do I identify my slope? Well, I need another point to get to, and it doesn't matter what point we choose. I can choose this point right here, this point here, here. There's an infinite number of points to choose, but remember, there's a few of them that actually work out pretty well. I'm going to choose one that might feel unusual to you. I'm going to choose this one right here. And the reason for that is because if you had chosen this point right here, you will still get the same answer. I'm just going to show you that this ends up reducing. So again, all we do is count. I go 1, 2, 3, 4. So that means I go up 4. Now, how much to the right do I go? Well, that's up 2. Excuse me, right 2. That's right 2. So this reduces. 4 divided by 2 is 2. And so now that we have my slope and my intercept, I'm going to substitute those into my slope-intercept form. The 2 goes there, and my 1 goes there, and I am done. Here are 3 for you to do. Go ahead and take a few moments to try that and then check your answers. And here are the answers for the 3 here. This is a horizontal line, so notice that my m is 0. My slope is 0, so the x part drops out, and you're just left with this. This has a slope of 1, and we don't need to write that 1. This has a negative slope. We can see that from the graph. It goes down 1, right 2. Our next lovely little example here is that we're going to find the equation of a line from 2 points. So we're going to write the equation in slope-intercept form of the line that passes through these given points. Now, one option is to graph it. If you graph it, then you can count your rise and your run and then do all that. It gets way more confusing than you need. So here's the first thing. We're going to find slope. We can use our m equals y1, y2 minus y1 divided by x2 minus x1 to do that. Next, we're going to substitute the slope and 1 point into slope-intercept form. And lastly, we're going to substitute the slope and the y-intercept, which is b, into y equals mx plus b. So notice that we're coming back. We're going to use y equals mx plus b, and then we're going to end with y equals mx plus b. We know that because write the equation in slope-intercept form. Turns out we're going to use slope-intercept form as well. So step 1. I like to draw little arrows here because this is my second y, and it's a little bit easier for me to see. So y2 minus y1 gives me 1 minus a 3. And then I do my second x, negative 3 minus a negative 1. Negative 3 minus a negative 1. That visually gives me what's on top and what's on bottom and helps me to be consistent too. Next, I'm going to simplify this. So I get negative 2 in the numerator. Double negative here is positive. Also negative 2, and this reduces to 1. So step 1, found slope. Step 2, I'm going to take that m, and I'm going to choose one of the points and plug it into y equals mx plus b. So step 2, y equals mx plus b. So which do I choose? It doesn't matter. If I choose the first one right here, then the 3 is going to come first. 3 goes there. So 3 equals, I have my slope, which is 1, so that's going to go here. My x value is right here, a negative 1, and that's going to go here. And my unknown b is right there. So finish this problem up. I get 3 equals negative 1 plus b. Add 1 to both sides, so b is 4. So what's my last step? I'm going to substitute back into slope-intercept form my 1 and my 4. So my 1 is going to go here, and my 4 is going to go there. So y equals 1x plus 4. And I'm going to simplify that. 1x is not needed, so I just simply say x plus 4. There we go. Now it's your turn. Please take a moment to try these ones out, pause, and check your answers. And here are the 2 answers. The last thing we're going to look at is an application. So Zachary purchased a computer for $1,800 on a payment plan, which I don't suggest doing. I would suggest paying cash all the time, but this is what he did. 3 months after he purchased the computer, his balance was $1,350. 5 months after he purchased the computer, his balance was $1,050. What is an equation that models the balance B after m months? So let's address this and see what we actually have. It turns out this is exactly like the problem we just did. We have points. So usually we have x and y for our points, but let's see what things represent here. This represents the number of months, specifically the number of months after I've purchased. And this here represents the remaining cost. So there's a couple points here, and notice that this first one was right here. After 3 months, I have $1,350 left, or he has. So that's going to look like this. 3 months and $1,350. Well, what's the other point? Well, there is another point here, and let's see what that one is. After 5 months, he's got $1,050 left. So 5 and $1,050. Now, there is a third point in there. It turns out it's right there. But wait a minute. Where did that come from? Well, that ends up being 0, $1,800, because on the 0th month, the month that he purchased it, he owes $1,800 on it. We'll come back to that in a second. So, step number 1, we're going to find slope. So slope is, remember, y2 minus y1 over x2 minus x1. In this case, I'm subtracting my y's here. So 1,350 minus 1,050 all over, and we're going to subtract this, 3 minus 5. Okay, now let's continue on. Here we have 300 divided by negative 2. That gives me negative 150. Now, the next part actually is using a point and plug in. Well, it's actually much easier than that. We actually know what B is right here because that's where we begin. We begin at 1,800. So if you were to take that point and plug in 1,800 here equals negative 150x plus B, and x being 0, then B is 1,800. Now, we didn't have to go through that. Conceptually, we knew that to begin with. So, and finally, step 3 is y equals mx plus b, negative 150x plus 1,800. Now, next question. What does the slope signify in this equation? What does that represent right there? Slope. What does slope here mean? Well, my slope is 150 with a negative. But what's the units? Well, it turns out it's dollars per month. So what does that mean? That means Zachary is paying $150, and the paying part, the negative, is the paying part per month. And there we go. All right, your turn. You will finish up how many months will it pay off, and lastly, what happens if we change some of the data here. All right, enjoy Slope-Intercept Form.